Welcome to the YesDev channel and the Code Wars series, where we solve katas from the Code Wars website in Rust for fun. So let's get to it. This is part 2 of the kata directions reduction. This time we will take our solution from the last video and transform it to a more functional approach using the fold function from the iterator trait. As a quick catch-up to the kata, in this problem we get an array of directions and we have to remove consecutive opposite directions. Should, due to that removal, two opposite directions be consecutive again, then we have to remove them again. So in our final array, there shouldn't be any consecutive opposite directions. If you want to know more about the problem, please watch the first video where I go over the problem in more detail. Now that we are all caught up, let's get to the actual implementation. Now, this implementation is working as expected and is itself completely fine. But what I would like to do is take this approach and make it into a operation using the fold function from the iterator. And yeah, let's see how that works. So when we think about it, it should work pretty similar like our while loop, because what we simply do is we iterate over our entire array and backstep if necessary. What we can do here is simply use the fold function and pop the last element of our array in case we had a match with this here. So let me show you what I mean by simply implementing it. So we keep our array and we simply iterate over it. And then we use the fold function and initialize a new vector. Now we need our closure here, which takes in an accumulator, and afterwards our next element. And as we need a bigger body, let's do it like this. And as we're gonna return this anyway, let's remove the while loop here. And also we now don't need to define these two, as we iter over the array and we can iter over the slice instead of the vector. That won't make a difference. Now that we have these two, let's match against them. And let's take the last element of our accumulator, which in the first case would be nothing. And that is why last actually does not return the value directly, but last returns a option. So we have a none or a sum of a direction. So, and as the second element, we just take next. And then we can match again against our directions that we have, or that we had, but we now have to wrap the first element into a sum. So we say, let's make the first case, we say sum direction north, and then let's not use the reference here, but the actual value, place a reference here. And now we can say direction south. So that would be the first case. Let me quickly fill out the other cases. Now that we have the other cases, let's first do the case that this is not true, as this helps to get the mental image of what is actually happening here. So now we also use the default case. So this would match if we have a none here, which would be the first case when we didn't execute this closure before. I forgot this. And in this case, we only want to use the next here, or better said, we only want to use the next we have up here. And we want to insert this into our accumulator, or push it into the accumulator at the end. And now we have the next in our accumulator here. And that means we now have we have the first element here, and then we now want to handle the case where we have the second element, so we can actually check against something here. And in that case, for example, if we have north and our next element is south, then in that case, we do not want to add the south, so our next, and we want to remove the north, the north direction. So we want to pop from our accumulator. And this way, we now have, covered both cases. And if we think about the whiteboard case again, here, now that north and south is removed, the top element of our accumulator becomes again the first element. So let's go down here and see that again. So these two would be removed. Then we would have southeast, which would be fine. And then these two would be removed. And now next would become north, and the top of the accumulator would be south. So both would be removed again, as this would not be added, and this and south would be popped from the accumulator. So we get the result we actually want. Now that this is done, let's quickly fix the error up here. The error in this case is that we are not returning our accumulator, but we are returning the unit type, so void in other languages. Let's quickly put that here, save, and now we see the only problem is that accumulator is not mutable. And now that this is mutable, this works fine for the compiler, and let's see if it works fine for the tests as well. And as we can see, all tests run through. And yeah, then let's take this code and submit it to Code Wars. Now back in Code Wars, we can attempt it and submit it. Now, when looking at other solutions, they are pretty similar. Here just for loop is used instead of fold, otherwise a stack is used and it's popped or pushed. And here similar as well. And this person here used an interesting approach, very well commented. It used here wrapper U8 and could use that to use a binary operation for, a binary AND for the binary numbers they assigned here to the different enums, and then check if they are inverse in that way by not having the same binary digits set to 1 for opposite directions. And yeah, I find it a quite interesting approach. And yeah, very well documented. Yeah, but other solutions are pretty similar in what they are doing and nothing quite too interesting. I'd wrap it up here. I hope you had fun with the video and learned something about Rust, and I hope I'll see you in the next one.